In this video, we are to discuss all the characteristics function of a random variable. We are also to derive some of the standard distribution. For this case, we'll take that of the standard normal distribution. The first thing to do is to write the distribution of the standard normal distribution. For more on this topic, you need to subscribe to this channel. So the distribution for the standard normal distribution can be written as negative 1 over 2 x squared. So we have 1 over square root of 2 pi exponential negative 1 over 2 x raised to the power of 2. So this is the distribution for the standard normal. Now, we also know that the characteristics function can be written as exponential itx, which is equal to the integral from negative infinity to infinity. Then we have exponential itx multiplied by f of x dx. What this simply means is that this I here is the characteristics function. Exponential f of x, which is the distribution for the standard normal, which we will now impute to get our derivation for the characteristics function. So we can write our characteristics function to be the integral from negative infinity to infinity exponential itx multiplied by our distribution, which is 1 all over square root of 2 pi multiplied by exponential negative 1 all over 2 x squared, then dx. So this is what we get. Now, we can bring this out because it's like a constant, so we bring it out. It then means that our characteristics function can be written as 1 all over square root of 2 pi integral negative infinity to infinity exponential the characteristics function tx multiplied by exponential negative 1 all over 2 x squared, then dx. So the next thing to do, we have to combine this exponential function. So we move over to this side of the board. Combining these two exponential functions, we have our characteristics function to be equal to 1 all over square root of 2 pi. 1 all over square root of 2 pi into negative infinity to infinity. Then we have exponential. We can take this first, negative 1 all over 2. Of course, we open a bracket to give us x. We have x squared minus, to bring this, it will now be 2 itx, then dx. So this is what we get. This is what we get when we combine this. The next thing to do is to expand what we have here. So if we expand it, we get our characteristics function to be equal to 1 all over square root of 2 pi into negative infinity to infinity. So we're expanding this exponential negative 1 all over 2. We put the bracket like this, then x minus it squared minus it squared, then dx. So this is what we get if we expand this. This is what we get. Now, we'll have to bring this out again to give us our characteristics function to be equal to we bring this out because this can go into this and it can also go into this. So we take this and this to write exponential negative 1 all over 2 t squared. The characteristic function will go off because of the square sign. Now we have multiplied by this constant, which is 1 all over square root of 2 pi into negative infinity to infinity. Then we have exponential negative 1 all over 2. Then x minus it squared dx. So this is what we get. Of course, the whole of this is equal to 1. So we have our characteristic function of x to be equal to exponential negative 1 all over 2 t squared multiplied by 1, which is the whole of this. So it then means, therefore, that our characteristic function is equal to exponential negative 1 all over 2 t squared. So this becomes our derivation for the characteristic function of the standard normal distribution. For more on this topic, you need to subscribe to this channel.